So, good evening, everyone. Welcome to the webinar of Gen AI. So, again, we're back with the topic of prompt engineering techniques. So, today we're going to talk about tree of thoughts. Tree of thoughts prompting technique is basically a systematic framework which will transform how an LLM will inference a structured search. So this was introduced in the year 2023, and it has been shown to dramatically, improve the performance of a lot of tasks, which involved non-trivial planning, giving mathematical insights, or even creative exploration for that matter. Now, where did actually this motivation of tree of thoughts come from? It is in contrast with the previous method that we have seen, which is chain of thought. So chain of thought prompting will basically, it's a single linear chain of intermediate steps, right? To ultimately solve the task at hand, it will think of the each and every intermediate step and then arrive at the answer, right? And it will also explore an alternative answer, okay, once chosen. Tree of thoughts is a little different. It will generalize a chain of thoughts by maintaining a tree of partial solution or partial thoughts. At each depth, the model will basically branch out into multiple thoughts. It will evaluate those multiple thoughts and then prove the suboptimal paths. Much like how a human brainstorm and he will backtrack any sort of strategy. Similarly, this tree of thought works. So, what are the core components of tree of thought prompting? Are thoughts, the proposed prompt, the value prompt, and the search algorithm itself. What exactly are thoughts, right? They are coherent text spans which represent intermediate steps towards solving the target problem. For example, an arithmetic equation or any plot or even a crossword to fill a crossword. Then we have the second component, which is proposed prompt. This is a given a current partial solution, how the model is prompted in order to generate a set of candidate next thoughts. Then you have value prompt, which is each partial solution along with the new thought is scored, typically via the model's own ability, which is again a negative loss, or a specialized evaluation prompt in order to assess its promise. Then finally, you have the search algorithm. It's a classic search algorithm which is applied over the tree. So you will have depth, the number of thoughts that are generating, branch factors, the candidates who are proposed per node. Then you also have beam width, how many top scoring nodes to retain at each level. And how does this actually work? You will start with the root node containing the original prompt or question. Then for each depth level, you will do iterative expansion. That is for each depth level, for every surviving node, use the proposed prompt in thoughts. Okay. Attach each of those thoughts to its parent sequence, forming a new partial solution. When we use this value prompt or model logarithmic probabilities in order to score all the new candidates. Then comes pruning, which will keep only the top B sequences globally scored on the globally based on the score. And then there is termination. So after D rounds, select the highest scoring full sequence as the final answer. So what are the benefits of using this tree of thought, right? So in Yao experiment on three challenging benchmarks, which is game of 24, mini crosswords and creative writing, tree of thoughts was achieved. So game of 24, this is GPT-4, generative pre-trained transformer 4, along with chain of thought, has solved only 4% of the puzzles. Whereas when you're using tree of thoughts, it has reached 74% success, this game of 24 game. Then when you're doing crosswords, when you're filling in crosswords or you're doing some creative writing, this will significant, we've seen that train of thoughts will result in significant gains in coherence and correctness by avoiding local dead ends. When do we actually use this tree of thoughts? When you're doing complex planning, any type of puzzles you have to solve, any type of multi-step mathematics, logical inference, any creative tasks that you want to do, creative tasks like story writing or code generation, right? Where early choices will deeply impact the later choices, later quality. Then any problem which basically demands a strategic look ahead, or where backtracking can avoid unproductive paths, we basically end up using this um, tree of thoughts prompting. For simple reasoning or standard chain of thoughts, or maybe zero shot chain of thoughts, uh, for any sort of simple linear reasoning, chain of thoughts can suffice, right? But tree of thoughts is when things started getting more complicated, more strategies are involved, more complex planning is involved. You have to solve a puzzle, you have to solve any sort of creative tasks. Then we opt for this tree of thought prompting. Now let's get into this example code that I have here. Let's first try and understand how this code works, and then we can probably get into, let's discuss the code itself, right? The first thing that you need to do before you run this code is basically install the transformers transformers accelerate. Okay, and then you can run this code. So the first thing that I'm doing here is basically fetching the code in the sense that in order to simulate the multi-step reasoning that is used in tree of thoughts, we're going to use an open source LLM, which is Mistral 7B Instruct. We're going to break a problem into a tree of thoughts. We're going to explore all the different possible reasoning paths, that is, thoughts at each level, and then keeping the most promising ones using the beam search. We will then return the best thought part at the end. So step by step, let's look at this code that we have. The first thing that we're doing is importing certain set of libraries. So transformers, which is a Hugging Face library in order to load the LLMs. Torch, PyTorch library for your GPU acceleration and tensors. Then we have head PQ, which is used for implementing a max heap to pick the top thought paths. Then what we're doing, the step two is basically loading a pre-trained LLM from the Hugging Face. So here we are taking the instruct tuned LLM, Mistral 7B, and we will basically initialize a float as 16 because this will use less memory, again, faster on GPU. Device map as auto so that whichever GPU, CPU, whichever thing is available, it will take up that one. Then this pipeline and all, it will set up a text generation wrapper. Okay, and auto tokenizer is using the appropriate token for a tokenizer for the model that you're using. Okay, we will now create, first thing that we're doing is we're creating a node class for each thought. So each node represents one stage in the reasoning tree. We basically track the text or the prompt, okay, the depth of the tree, and a score which is used for ranking. And this IT basically defines how nodes will be compared in the priority queue. Higher the score, better the path, or better the node or thought. Now we're going to start generating thoughts. So how do we generate thoughts here? It uses the LLM to generate multiple completions or multiple thoughts for a given prompt. When we say do underscore sample is equal to true, it will ensure the sampling for diverse outputs. It will remove the original prompt from the output text, leaving only the generated part. Then we are going to also evaluate each of our thoughts. So how do we evaluate? This is a placeholder scoring function. It will simply score a thought based on its length. You can replace this with either sentiment analysis or with LLM based self reflection or task specific accuracy. Then we are going to execute. So, tree of thoughts execution, core execution is given here, code logic. How does this code logic work? Right? Or rather, I'll say from here to returning the best complete path, we have the core logic. It first starts with a root prompt. It will repeat for a number of tree levels. That's what max depth function is going to do. For each node, it will generate multiple thoughts, score each of those thoughts, create a child node, and store them. And then finally, it will use beam search to retain only the top scoring children. After finishing this, it will pick the best final path. Now, if you see this example problem, basically provides a reasoning heavy problem and it prints the best multi-step thought path returned by the tree. Think of the visual. So visualization of the tree will be a sort of like a tree structure. This kind of tree of thoughts will basically allow us in doing better. So how else you can sort of improve on this code further is look for better scoring. That is, instead of doing just based on the length of the thought, you can also use LLM self evaluation, or you can use a classifier over there. Then you can bring self consistency. You can sample many completions and vote. There is also DFS, depth first search alternative. There's also parallelism, that is use async for faster multi-thought generation. A lot of improvements can be made in this tree of thoughts. Very, very interesting prompting technique and a pivotal prompting technique, especially if you are involved in doing a lot of making a lot of strategy decisions at your workplace. Then tree of thought prompting would be really helpful for those kind of projects. So that's it from my end today regarding the tree of thought prompting techniques. We have a couple of more prompting techniques maybe next week and the other week. Two more prompting techniques left, and post that we will deep dive into lot of other exciting things within generative AI. So please, thank you so much for tuning in today. Hopefully, we will meet back again next week. Until then, signing off. If you like the video, please do like, share, subscribe, comment, give us your feedback, valuable feedback. Let us be on this journey of upskilling ourselves in the field of generative AI. Thank you.